Hello, everyone, and welcome to this month's Newcastle Discover, the latest in our Discover series. For those of you who are joining us for the first time today, the Newcastle Discover series is brought to you by our Newcastle University Alumni Engagement Team and aims to encourage lifelong learning through thought-provoking and insightful events on the latest in university research and practical life skills sessions. This is our first instalment of the new academic year, and I'm delighted to be back with you all today. This year's Newcastle Discover programme is a little bit different as it is aligned to our NCL in Action theme, which is exploring AI's impact on our world. This is our year-long programme of events and volunteering opportunities that are designed to help you explore the ways in which AI and future tech could potentially change all of our lives and the way we work. In the Discover events, expect to dive into the university's cutting-edge AI and tech research across disciplines and across industries, as well as how AI tools and technology can support us in our everyday lives. My name's Lily Moore, Alumni Engagement Manager here at Newcastle, and I'll be your host for today's event. As always, a huge thank you for joining us today. So, moving on to the content of today's event, AI, the good, the bad, the ugly. Today's masterclass will discuss the current landscape of AI and some of its impacts and consequences in our world today. We will explore how AI through a few different lenses to assess the current state of the good uses in AI, the bad uses, and the ugly side in terms of how exploitation of AI can erode trust. I'm really delighted to be joined today by Dr. Scott Stainton, NU alumnus and technology director at Collaborate, a human-centered data and AI company primarily focused in the secure government and law enforcement space. This is where Scott leads their data and AI technology strategy. His prior life in academia started right here with his PhD at Newcastle, investigating the use of AI in communication networks for autonomous vehicles, and subsequently moved into the field of AI for low-powered embedded devices and medical imaging. Before joining Collaborate, he co-founded an AI consultancy that received a National Startup Innovation Award and is a member of the all-party parliamentary groups for both AI and blockchain. So without further ado, Scott, huge welcome. Thank you for joining us today, and over to you.
Thank you very much. So as Lily said, I'm Scott Stainton, former Newcastle alumnus from the School of Engineering now. I'm thrilled to be here at the first instalment of this event. AI, the good, the bad, and the ugly. So let's dive into it. Of course, I couldn't have the talk named Good, the Bad, and the Ugly without at least making a few references. So forgive me if I indulge myself throughout. It's a little bit of the format of this talk. We're going to cover what is AI. We're going to go through sort of a brief history and terminology. Hopefully that will put us all on a sort of level playing field so that we understand when we're talking about AI, what actually is AI. It's been talked about a lot in the news, in the media, probably in all of your roles. There's a lot of hype and hysteria, and there's a lot of misnomers and misconceptions. So we're hopefully just going to cut through some of that with some of the history and some of the terminology. We're then going to go through some good use cases of AI, a little bit around medical diagnostics, a little bit around law enforcement, so some of the areas I'm currently working now. Look at some bad AI uses, so some misinformation. Try to make this more exciting because we're probably all sick of hearing about deepfakes, although spoiler alert, they do make an appearance here. So come up with some more exciting ones like autonomous terrorism and chemical weapon synthesis. A bit more far-reaching, but we'll touch on those later. And then a little bit about the ugly side of AI. So this is probably, unless you're in the field of AI, a lot of things that you may or may not know about the AI market, and some of the things around how AI models are generated and put out for use. I'll finish with some future thoughts. So as we jump into the history, I start with a brief disclaimer out now. This is aimed at people who are maybe on the fringes of AI. If you are an expert in AI, we're not going to go into the real inner depths of what some of the cutting edge stuff is now. I'll talk about LLMs briefly, but hopefully, as you see, as we move into our history, we're talking about a field that is almost 100 years old. Um, artificial neurons were first proposed back in 1943. Um, Granted, they didn't propose them for AI purposes, but the actual mathematics around trying to create a mathematical model of how the human brain operates is what they were devising back in 1943. And if anybody's heard of types of machine learning models called neural networks, they are based off this principle. In 1950, we all know Alan Turing. He's on our £50 notes now. He first proposed the Turing test, or as he first coined it, the imitation game, is where the film got its name from. But that wasn't until 1950. And this is still pre-invention of the computer. It wasn't until 1956 that the artificial intelligence as a phrase was first coined as a term. And then we had a few years that aren't really of much interest to anybody except AI researchers. But the next sort of point of note was around 1997, where IBM's Deep Blue algorithm beat Garry Kasparov, which, if anybody remembers, was a chess grandmaster at the time. A lot of people credit Uber and other people with creating the first autonomous vehicle. A lot of it actually goes back to research academia does and other institutes, government bodies. There was actually a DARPA grand challenge in America in 2005 where an autonomous vehicle drove 131 miles across the desert terrain. And to put that into perspective, I think it was 2013 when Uber and others were coming out with their autonomous vehicles. 2011, I like to note, this is when Apple released Siri. Siri, not many people thought of potentially as AI at the time, but it is AI, and it was the first sort of ubiquitous release of AI, and ended up in most of our pockets in a small device. So 2011 sort of marks that era. Coming from 1997, where IBM, the Deep Blue algorithm, beat the chess grand champion, after that point, it was basically impossible for a human to beat a computer at chess. Even without the use of AI algorithms, computers were then at a point where you could just pre-compute all possible moves in advance, and you could never beat a computer at chess. So the world of AI had to move on and find a new game, or a new way of performance benchmarking. So there's a game of Go. It originates from the Far East. The Go, there's more palpable board positions and moves in the game of Go than there are grains of sand in the universe. So this is a game that currently, on current computation and immediate future computation requirements, we can't just pre-compute all the moves, which means that we know that we have to come up with an algorithmic way of playing the game. But 2016 was the first time that the reinforcement learning algorithm, so a branch of AI called AlphaGo, beat the current Go world champion. And then 2018, this gets a little bit more technical now, but Google released a model called BERT, and OpenAI released a model called GPT. This is back in 2018, so 6 years ago now. But you might recognize that GPT from ChatGPT. So GPT, technical acronym, stands for Generative Pre-trained Transformers. Transformers being the underlying sort of technical advancement that was made here is the same as the T in BERT as well. That's a transformer as well. This was the first evolution of the technology that would later enable ChatGPT, and then 2023 of the release of Bard, Claude, all the others that you might be familiar with now. And so given that this field of research has been going on for over 80 years now, why is it that we have so much AI going on right now? We've only heard about it in the last 5 years. I like to think you're really simplifying it down. Artificial intelligence is this sort of intersection where maths meets computer science. We have had the ability to do maths, obviously, for centuries, millennia, but computer science has been the thing that's been holding us back for a long time. The actual ability to enable this use of maths at large scale requires at the minute, if you're involved, you need GPUs or PPUs, these compute accelerators to enable AI to perform at its best efficiently. There are threads of research trying to come up with alternative ways of running models or making models smaller so they run on more power efficient devices. But this has been the main thing holding AI back. And it was where the real breakthrough started coming through in the early sort of 2010s around the ubiquity of the reason NVIDIA this year that became the most valuable company in the world. NVIDIA is a company that produced the prevalent GPUs, so the compute accelerators for artificial intelligence. Very sweeping statement here. There are no AI models that don't operate on numbers. Those in academia may choose to fight me on that point. Very broadly speaking, there are no AI models that don't operate on numbers. But that comes from the fact that these AI models run on computers, and computers don't actually deal with other concepts. It's all binary. And even when it comes down to the mathematical operations here, looking at maths as that right-hand intersect of artificial intelligence, any sort of input we have, such as this is a string of text, hello world, what the computer and the AI model actually does is convert that into a vector of numbers, which we then input into a model. The model runs its maths and we get an output. And then we reinterpret the numbers back, as text or as whatever that model's function is. And that's when I'd highlight that AI models are mostly built for singular tasks. Again, coming back to the fact that these are mathematical operations, for instance, even using ChatGPT as an example, as that's something you think you can use for lots of purposes. All ChatGPT is doing is, I'm not going to call it glorified predictive text, but it is generating text based on an input. So all its singular task is to generate text. Same for generative AI images, you're generating an image. Same for any prediction model, you're predicting around a particular singular task. And that's where, if you've heard of terms like narrow AI, or as we go to the opposite end, where people are worried about artificial general intelligence, the sort of the looming Skynet threat that people like to talk about. Because we are built around singular tasks, for most artificial intelligence these days, artificial general intelligence is that leap where, a bit like Einstein's general theory of relativity, we don't have a general set of mathematics that can model every task that we might want an AI to do. Again, just highlighting when we say artificial intelligence, what do we actually mean? So artificial intelligence has its own definition. It's development of systems that are able to perform tasks that normally require human intelligence. Now, within artificial intelligence, you may have heard of machine learning, and is a subset of AI, where we give computers the ability to learn without explicitly being programmed. Within machine learning, you can again break it down to supervised and unsupervised learning. Within those, they have their own subtopics. So we have classification and regression for supervised learning. We have clustering and unsupervised learning. There was one you can argue that's a mix of both, called semi-supervised learning. There's a sort of middle ground between the two that has its own classifications of algorithms. But leaving machine learning aside for a second, if we then went one level deeper into all of these, if you actually notice at the bottom of all three of those middle diagrams, we have neural networks. So again, going back to that 1940s research of trying to model the neural activity in the brains, we end up with neural networks, which is where we branch into deep learning. So these are machine learning algorithms with brain-like logical structure called artificial neural networks. I've given a special shout out to reinforcement learning there. It's another subset of machine learning that sometimes crosses over with deep learning. Again, all of these analogies can break down if you put them under a microscope too much, but very generally, reinforcement learning, I gave it a shout out there because it's what, with the AlphaGo, it was a type of algorithm that beat the AlphaGo world champion, sorry. They are generally very difficult in a practical sense to make use of. So you'll generally find very few use cases or studies of that. You generally need a really good, they call it digital twin. You need to be able to actually let an agent operate in an environment that mimics the real world. So in the game of AlphaGo, we can actually give it a proper environment to act in. It can play the game itself and learn. If you want to get reinforcement learning to, um, I don't know, learn to drive a car, you have to create all of the real digital representations of all the physics to let it learn in that digital environment. So it's quite difficult to enact in the real world. And then going into neural networks further, you probably can't see this as it's too small. It actually says that is a mostly complete chart of neural networks. And that was from 2016, which is an even smaller writing there. So as you go down and down through these layers, so under deep learning here, we're looking at the neural networks. We have just hundreds of different types of algorithm and model and setup. All this just goes to say artificial intelligence is an absolutely enormous umbrella term, and it makes it really difficult to have meaningful conversation, especially talking about things in the media or in the news. When you just throw around the word AI, we don't know what scale, what end of the scale we're potentially operating at without more context. But to give you an example of that, what is an AI model? Fundamentally, we take some data, we put it through a model and a learning algorithm. So going back to the fact that this is maths, and run it on modern hardware. So bringing in that computer science element and to actually get through the learning. Now at the other end, we get a trained AI model. Now what that model and learning algorithm could be is something like this is the back propagation algorithm. So this is for those neural networks that we were just talking about. This is one way of training them. This is quite complex, obviously, from a mathematical point of view. But on the flip side, if you were to do a standard regression, but if you've ever had some data that look like that and you put a line of best fit on, what you're able to do there is make predictions about future values using historical information that you have. That is an AI model. You have built something with the ability to predict a future event. So again, just going back, AI is this massive umbrella term, and without much more context, you could be looking at the really complex mathematical side that's really hard to explain. People call them black box models. You could be at this side, which is the more explainable side, but the less complex mathematics. It just requires a bit more context. Now, a little forward on LLMs, because LLMs, like ChatGPT, probably the reason a lot of people have heard about AI making the news between LLMs and image generative AI. My personal stance on this is that this is an evolution of technology. It's not meant to replace humans. So LLMs can be used by lots of different types of people. And as we go forward, I'll show you some examples of why I don't think it should be used to replace people. Again, these are a couple of silly examples, but if you ask ChatGPT what the current time is, it has various means of telling you now through plugins and other things. But as a pure AI model itself, going back to the fact that it's just there to generate text and generate text based on stuff it's learned from in the past, it's not actually a cognizant or self-aware model. If you ask it the current time, it can't tell you. Or in the second example, if you ask it to reverse the letters in the word lollipop there, it's produced something obviously very confidently that is incorrect. Now that's just a simple example, but it highlights the danger of people putting stuff into ChatGPT and just blindly trusting the output. Now here's an example from Microsoft, September last year. Yep, the amount of data these things take is enormous. Nothing here actually ended up in the wrong hands, but just to highlight, when dealing with this amount of data, you have to know where your data is going. and you've got to be treating that sensibly and securely. Another example here from last year, there was a not-for-profit, so this one always baffles me. It was an eating disorder charity in America that all of their volunteers are already volunteers. They're not being paid. But they let go of all of their volunteers and replaced it with a chatbot. Now the chatbot, within weeks, started giving out harmful health advice to people coming to an eating disorder charity. It eventually, the entire charity got closed down. But that one baffles me. I don't know why you get rid of resource you're not paying to replace them with AI, which then fail. But other examples of people jumping on the LLM bandwagon is DPD. I've blurred the flower out. I think I've caught them all throughout this presentation. But yeah, before large language models, we had perfectly good means of implementing chatbots through natural language processing to another type of AI, things like intent. LLMs are really powerful, but they're really easy to get around the guardrails at times. For instance, it ended up on Twitter. You may have seen it earlier in the year. My personal favorite one is that bottom middle one there. Asking it to write a haiku about how useless DPD are. It's not particularly the best response, but what I like about it is the irony that it's not a haiku. It's not the right number of syllables. So again, it's confidently produced something that is not correct. And then again, there was Air Canada replaced their service agent with an LLM. Now, the LLM ended up giving out bad information about policies and discounts. And Air Canada's legal response was that they tried to claim that the chatbot was responsible for its own actions and that they weren't responsible for information that the chatbot or the LLM gave out. So that's a nice try. That would have been a very dangerous precedent to set if that went through. But it does bring up a lot of interesting legal questions. We have legal entity representations of people and businesses, but currently there's very little around the legal sort of regulation around AI. Let's go through some of the good use cases of AI here. So in my opinion, working in the law enforcement space, there's a lot of parallels to healthcare. For instance, we've got lives at risk. You're deeply sensitive to the ethics of what you're doing. You're deeply sensitive to bias. You're understaffed. You're going to be wary of outsiders. And AI can be used as an accelerator. I like to mention medical healthcare here because it's actually been used for a long time in the medical and healthcare space. A lot of algorithms that 10, 20 years ago, we might just have classified as computer vision or image processing or other clever algorithmic or statistical methods and names that we would have. These days, the marketing team would just brand it as AI. It's not necessarily wrong. Again, going back to the very broad umbrella term that is AI, it's just a little bit misleading. But we've been using things that would be AI in the medical space for a long time. Again, there's lots of problems with potentially using bits of AI. So again, there was a case in South Wales where the police lost a facial recognition case. It breached privacy and equities law, allegedly. That's what the case was about. Again, I like to use this case just to point out that any technology could be used wrongly. So in this sense, the privacy is the context with which the privacy breach with the context in which the technology was used. There's lots of different uses of privacy being breached using different types of technology. So that is not AI's responsibility there. But the equalities law, that is around AI itself and the data it was trained on and all of the metrics that support that. So that is a concern of AI and one that we should be wary of. And again, going back to that fact that AI is for singular tasks, a really subtle one, for instance, is facial detection is not facial recognition. So an example here of doing age and gender prediction from images. Yes, it has to identify that there is a fake present in order to try and detect how old they are. But just because it can detect faces doesn't actually mean it can recognize who that person is. It's a subtle difference, but again, it comes down to the maths behind it. So another AI use case, um, would you believe it? There's lots of police and law enforcement use cases around the country where there are people free to upload. I've given an example of YouTube here, but there's lots of sites where people can upload whatever they want in terms of videos. I've taken drill as an example here. There is a really good BBC documentary on drill. Again, not vilifying drill as a genre. If you're not familiar with drill music, well, go and look it up, or I'll actually play for some for you in a second. But using drill as an example here, we've got a playlist with 137 videos in, an average of 4 minutes. That's 9 hours of content that somebody may have to sit and listen to. For instance, in law enforcement space, there might be intelligence that somebody is threatening somebody in one of these videos. So we can use things like AI to perform transcription and then further out natural language processing analysis. I have missed some swear words, Lily. Sorry, they are very small though. So, for instance, this is the transcript of one of these drill songs, and just highlighting out some of those. What's a good one to say? Smoke man down there at the bottom. That's a potential indication that there's a threat to life there. They're going to shoot someone. Yep. Again, not vilifying drill. These are things that are regularly said in music videos all the time. But for those of you who haven't heard drill,
my youngsters are nutters, stay with the cutters, chef up you and your mother. 3-0 and got nicked for a Mazda, now he's doing life in the slammer. How many times have I circled the up block again and again to a man got slapped with a hammer? Bro was a well-known rider, I'll hop off a bike, watch the ops and sing like Mariah. It was screw and shots to the slap that corn when sh got bun, man it a liar.
Very small demo there. There was reference to threat in that video. And again, the ability to recognize and performing object recognition within images and videos. Again, these two examples here, it's very easy to retrospectively go back and say, oh yes, there was a knife or there was a gun present. But putting it in more forward use cases, such as these CCTV control rooms. So most areas have one of these, but there's over 100 screens here with 100 different camera feeds. It's very difficult to try and perform threat assessment in real time against all of these when you've maybe got a handful of operators on the case. So again, it's not about replacing them doing their job, because somebody has to ultimately make that call, but you could maybe perform some high level augmentation for them to try and prioritize what they might be looking at. So now we get into the interesting bad uses of AI. I'm not going to talk forever about deepfakes. Voice clones, I think, are very interesting, especially combined with deepfakes these days. You have the ability to create these false narratives what might be dangerous in places where media is controlled. For instance, you can think about what might be happening in places like Korea and Russia right now, for instance, where with this technology, we have no idea what that internal story might be. And destabilizing collective decision making. So again, on a grand global scale, since the lockdowns and COVID and the resurgence of things like the flat Earth narrative, is it a coincidence that we've seen all of that resurgence around the same time as large language models have been released? There is no answer to that. I think it's a really interesting one to ponder. But again, I said I wouldn't dwell on deepfakes. I just wanted to play a quick video of the first deepfake that ever really caught my attention, and this was back 6 years ago now, 2018. If you imagine this was 6 years ago, technology's only got better and better infinitely since then.
Is in the sunken place. Or, how about this? Simply, President Trump is a total and complete dipshit. Now, you see, I would never say these things, at least not in a public address, but someone else would. Someone like Jordan Peele. This is a dangerous time.
So it stops then. But that for me was the first deep fake that really made me pay attention to this as a technology. And again, 6 years ago, it's only gotten infinitely better since then. As a complete aside, this is the R9X Hellfire missile. So it was deployed since 2017 by the US in secret. It costs about $150,000 per missile. I can say it's not secret anymore. This is not secrets I'm giving out. This is publicly available information. But America would use this from manned and unmanned drones. It has these 6 little blades that pop out, again, for low collateral damage target elimination, if I can put it as nicely as that. It doesn't explode on impact. The equivalent I wanted to sort of draw your attention to was, instead of $150,000 for a drone, for £100 we can have a little autonomous quadcopter with a flick knife. This is just a freely available video on YouTube. I think it's fairly obvious what they're trying to portray here. But this is a video from, if you can see the tag there, 2015. So this is 9 years old. Now, for anybody following any of the conflict in places like Ukraine, there is a lot of drones in use in that combat. Again, going back 9 years, this is £100 to build this 9 years ago. You can see some of the prices actually in the description. Now imagine with use of modern AI with webcams, you could create a specific threat that understood the person it was meant to target, maybe an age range, maybe it could target things more various than that. If I leave that example there, that is a scary potential use of AI. Now this one's a bit more theoretical. This is what I refer to as chemical weapon synthesis. So we have this process for pharmaceuticals and for other skincare products and the like, of drug discovery, it's called. And we do in silico modeling, that we use AI and other algorithmic means to analyze the structure of compounds, try and understand or predict what interactions it might have with other compounds. You can see why that would be a good use case for drug discovery. It is very slow and very expensive to take things into a lab to test. It is really handy to use AI and this in silico modeling to produce a short list of things that you think have a better chance of having the intended outcome. So this is used in drug discovery a lot. But where you can see this happening the other way, instead of trying to find a protein that would act as a painkiller, imagine if you were trying to find a series of compounds that would shut down someone's immune response system or other things like that. Luckily, this is while it's fairly straightforward from a technological perspective to do the drug discovery part, it is very difficult to take that into the real world. So that in vitro testing, getting your hands on the chemicals, on the labs, we're not talking the average person can be doing chemical weapon synthesis. We're talking very well funded, potentially even at state level. But it's out there as something that is possible. For instance, this is the SARS-CoV-2 cell that shut down the world for a couple of years there. It binds a particular protein in the body, and there was research using AI to fast track treatments. Ultimately, that wasn't where the breakthrough came from. But again, thinking about it's this particular binding of protein to things in the body that if you can analyze with AI, there is the potential there to be researching things that have negative impact. Going back to chemical weapons synthesis. And lastly, just a very brief one on this was a research study that came out of Osaka University in Japan last year, I believe. The top row of images are images that were shown to participants of this study. Now, the participants were shown these images while they were in an fMRI machine. And what they did was they recorded the brain pattern using the MRI machine while being shown these images. And the bottom row is AI trying to reconstruct the image that they were being shown using only the pattern of brain activity that they recorded. Now, it's not great, but you can definitely tell when given the reference image what the original image was. So really scary, but really interesting area of research. A very quick thing, to run through some of the ugly side of AI, because it's not as exciting as the rest of it. A very quick shout out to actually having codes of conduct and things for use of AI. One thing I like to point out in UNESCO's particularly, so if you go to any of the large companies, they will have their doctrines and codes of policy for their AI building and definition. But I like to point out point 8 here around sustainability. Sustainability is often missed out of almost everybody's AI policies. These large language models in particular and other things use a large amount of computational resource. They're quite environmentally unfriendly. And it was actually only released, I think, this week that there's companies out there and organizations looking at building these super clusters of GPUs, going back to NVIDIA. If we could not try to draw any action from it, I think just be aware of the fact that sustainability should be in people's minds around this sort of next generation and evolution of AI going forwards. I think it is a big part of people's research efforts, trying to make these models smaller and more energy efficient. Again, Interpol and Unicry also released a responsible AI for law enforcement document a few years ago. Very briefly touch on bias. These are protected characteristics that are protected by law. You do not want to be breaking, if you're building AI systems, you do not want to be breaking any of these protected characteristic bias laws. But this is a well-trodden path. What's less well-trodden is other types of bias. So for instance, some people may recognize this image. It's often taught in statistics courses. The story goes, again, we're not sure if it's a true story or not, but the story goes that in World War II, American bombers were coming back and they wanted to know where to reinforce a plane in order to have it stand a better chance of coming back. Again, the story says that they said, oh, well, let's reinforce where the dots are. This is where it's being shot. So if we reinforce it where it's being shot, it'll stand a better chance of surviving. A little bit counterintuitively, you actually want to reinforce where the dots aren't. It's not magically not being shot where the dots aren't. It's just if it's being shot there, it's not making it back to account for itself in this data set. So actually, this is called survivor bias, and it says that data that you have might be data that has survived some process. So you're not actually seeing the full picture. Again, there was a similar story around the Brody helmet in World War I. Response and volunteer bias, another interesting one. People lie. People need a reason to participate. For instance, if you go and look at most customer reviews, you will see they're generally weighted towards the 5 and the 1 star. At 5 star, you've either received a voucher with your Amazon delivery that says give us 5 stars and this is for you, or you've had a really bad experience and give them 1 stars. So people lie. Likewise, when you do that, so that activity question, wait, ask you how many units of alcohol you drink every week. I don't think anybody's ever answered that one faithfully or truthfully. And then a little bit, I'm conscious we don't have too much time, but around the evolution of the size of these models, again, going back to the sustainability point. So these bigger models need more data and they cost more for what we call a full training iteration. Now, in 2018, that original GPT, it had 117 million parameters. Now, GPT-2 in 2019 came out and it had 1.5 billion parameters. Again, this is going to start not being to scale. But from what information we can see, OpenAI, who released this, is ironically not very open in their information about all of this. There's rumors that it cost around $50,000 to train GPT-2 for one training iteration, and that's just the technological cost of using the compute. That doesn't involve any of the research and development or human time. But in 2020, when GPT-3 came about, 175 billion parameters in that model, but again, rumors being that it cost $4.6 million to do a training iteration. GPT-4 came out in 2023. There's rumors that it's in the hundreds of trillions and that it cost more than $100 million to do a training iteration. That's not been confirmed, and I don't think will ever be confirmed. They're already working on the future and future iterations, and this is the sort of scale it has taken. But at the same time, back in 2019, a European venture capital firm ran a study that was then picked up by Forbes that said 40% of all AI startups don't actually use field of study in a material way in their business. Which, going back to how broad that AI term is, it's just amazing that they could fall short of the mark by that much. But it just goes to show how much people are latching onto this marketing and media term. But, why is it that all of a sudden, overnight, everybody became an AI company when we've just gone through the process of said it is quite difficult and mathematical to get involved? Well, while not everybody might have the capability and capacity to do a lot of that maths and the training of the models, what all companies do have is software development teams. Now, people like Meta, so Facebook there, Azure, Google, OpenAI, they all have APIs or web APIs that you can use to leverage large-scale artificial intelligence without actually understanding or building any of the AI yourself. That's a really cost-effective way of doing it, especially if you can use it for a niche, because like I said, all of these cloud providers provide fairly generic AI solutions. So if you can find a way to customize it, it's a great use of it. But it has limited customizability to the actual model itself. And if you're working in secure environments, you often can't have your data flowing back up to these public cloud companies who are potentially using that data to train and inform the next generation of AI. So where does your training data come from for large models? Well, GPT uses a large bank of web crawl data. Again, you're probably seeing lots of now case lawsuits coming about, copyright infringement and the like, because they've just gone and crawled as much public data on the internet as they can for their data sets. And there's a large portion of that which has come from Reddit, which I like to highlight because it will horrify a lot of people. So the Europol Innovation Lab expects that by 2025, 90% of all online content will have been produced with AI assistance. Which means that we're already fixing this. The amount of content you're seeing on the internet may or may not be user generated. And the genie's out of the bottle with all of these people offering LLMs. There is less and less data out there for first generation training data. And my personal opinion is, without a change in the sort of research field of AI, now data set that we were gathering from to train AI, the internet, is now essentially polluted. You can't use AI generated data to consistently train future AI models. I don't want to liken it to the AI equivalent of inbreeding, but that's essentially what's going on. AI generated content informing future AI models. So just to wrap up, we've covered the fact that AI is a huge umbrella term that encompasses almost a century of work. And like any tool, it can be misused, even with good intentions. AI models are mostly maths, so the ethics and bias is a concern of the training data, and the application use case gives it that context. Now, there's always use cases around you. Think about singular time-consuming tests, because they're usually used for singular purposes. And depending on how you apply it, you're either going to get the good, the bad, or the ugly. There you go, there's the callback. And it's really hard to find somebody who can help you through this because of all the hype. Just make sure you ask the right questions of anybody you want to get involved in AI with. And at that point, I give a special shout out to the Responsible AI Network. So our collaborator is a commercial and corporate entity. We do also run the Responsible AI Network, which is a community interest company. So it's a charitable endeavor where we try and get good minds and people in roles that are responsible for this implementation to try and foster the responsible adoption of AI going forwards. So feel free to reach out to me. And all of my information is here, and I'm sure will be shared after today. So thank you for listening.
Amazing. Thank you so much, Scott. Really, really insightful talk. When I'd first seen this content, it really helped me as a non-techie person just to get my head around the huge world of AI and all the kind of considerations we need to make when, we're starting to adopt it in either work or personal lives or whatever that might be. So yeah, huge, huge thank you. So everyone who's still on with us on the call, we have roughly just under 10 minutes for some questions and answers. So please send anything you want to ask to Scott through the chat, through the Q&A function, and we can, attempt to get through as many of those as possible. I'd quite like to just kick off, Scott, I guess, with you've touched on sort of regulations and things like that. And, where do you think we're in a place where we need more regulations around the use of AI? Is that a responsibility of individual organizations? Should we have an overarching sort of regulatory body, or what are your views on that sort of area?
It's a great question. It's a really difficult one as well. Thank you. I believe that we need regulation. So we currently don't have regulation. I believe the government set out and what they set out with the intention of providing some regulation, but in the end it got watered down to best practice and guidelines. Because I don't think, again, when you go on this journey and you understand how broad AI is, I think they quickly realized that it's going to be very difficult to regulate. And the stuff that was coming out, these large language models and generative AI, while you might want to regulate that, you're going to capture too much in your regulation. But I believe we need it. They say, going back to the cost of really getting involved in the generation of these sort of first generation AI models. If regulation was to come in overnight that disallowed or what you've been investing in, because it costs a lot of money, we need to have that assurance that if we're going to invest the money, even from a purely commercial point of view, that tomorrow the regulation is not going to come in and disallow it. So I think it's really important, but it's a very difficult and then thorny one to get involved in.
Amazing. Thank you so much. So we haven't had any questions through the Q&A or in the chat yet. So please, if you have got anything, we've just had one come through now. So for people who are kind of just starting out, I guess, with AI, would someone's asked sort of if there's any sort of recommended training platforms or anything like that that you could recommend to, I guess, the individual to get a bit more confident with utilizing AI for themselves?
Yeah, absolutely. I mean, if you're just getting involved into the very sort of early beginnings of it, there's a few very good resources. So Hugging Face is a model repository and dataset repository. You can go and find almost anything that you want on there. Um, the use of, if you want to actually test your skills, there's a platform called Kaggle. I can share all these links afterwards, but that's like a data scientist. You try and solve a problem, they will tell you how well you did based on the data that they've got. And then in terms of free resource as well, so having to use GPU, if you don't, a good sort of cost-effective option for getting your hands on a machine that's capable for AI with a bit of a title, because to buy a gaming PC or a gaming laptop, they usually have GPUs that are available that are consumer friendly that you can use for training yourself. Or there's places like Google Colab where you get access to GPU resource for free with a Google account. So those are a few very good sort of beginner places to get involved.
Great, thank you. And yeah, do share with me those links and we'll circulate them to everyone who's attended post-event. Two specific questions. I'll ask them both at the same time if that's okay. So we've had one question around, is there anything we can do to block sort of accounts or news that is clearly fake or potentially misleading? And how is there any way of us knowing how much of, say, a document might be generated by AI? Like, can we ever sort of know that as a user?
So can you clearly, it's going to give you a very boring answer about blocking fake people in that. Like, sadly, you're just going to have to use the block functionality on that particular platform. They might come back again into your newsfeed. I think try and stay off social media these days as much as possible. It is getting very overpopulated with clearly fake content, given how ubiquitous this technology is now. It's not an easy one to deal with either. So the flip side, getting companies to try and put in some regulation or some process to only allow real people is also really hard. But second question, how much of a document is AI generated? Again, really good question. And whoever can solve that is going to be a very rich person. The problem is that as soon as you think that you've got an algorithm that can detect how much of a document is AI generated, the algorithm that generated the content has moved on and your detection algorithm no longer works. So it's a constant cat and mouse game. Can you detect it? If you can, they will change how they do it so you can no longer detect it. Yeah, very difficult.
Yeah. So yeah, whoever's got that idea, let's roll with it and take it forward. That solution.
Sorry, it's both very boring non-answers, but
And I guess still, I'm just kind of going to summarize a question we've had in the Q&A from Peter, kind of on the same sort of line around sort of AI generated content. And he's kind of mentioned, there's a growing concern that the current rate, the proportion of AI generated content will actually outnumber user generated content, and kind of what are the responsibilities of our sort of tech giants or, social media giants or whatever, to kind of address this trend.
it's hugely in their interests, as well as us saying it should be their responsibility. I believe that they are trying. They are not succeeding, clearly. But going back to that problem of can you actually detect AI-generated content at huge scale, a global scale automatically is a very difficult problem. But they need to broach that problem because they need your data. Again, these social media platforms are provided to you for free. So you are the product of these social media platforms. They want your data. And they want your real data, not AI-generated content. It's in their best interest to try and solve this problem, but it is just a really hard problem.
Yeah. Fab. Thank you. And I want to finish with just one final question. Obviously, there's a lot of rhetoric around sort of AI stealing everyone's jobs, replacing humans, which you kind of talked about at the start. Do you think that AI will also create new jobs instead of sort of replacing, or even if they do replace, and kind of if so, what do you think they could be?
Yeah, absolutely, it's a really good one. I'm glad that was asked because I should have mentioned it at the time. Talking about the evolution of technology. So if you go back to the days before the computer, there was entire industries. I think about doctors' practices that revolved around paper.
Mm.
Now you had people working on paper-based filing systems and all things like that. They moved to computers, and those jobs disappeared overnight. Now they adapted and got new jobs, and the whole landscape changed. But it didn't replace jobs. It just adapted the way we actually do business and do interaction. So I think the same thing will happen with AI. For instance, you might not have to do a control F to find something in a document. You can just ask what you're looking for. It will find it, regardless of whether it exactly matches or not. Bad example, but technological advancement not to replace humans. And if entire jobs are made no longer relevant, there will be new ones that are relevant.
Yeah. So an adapt rather than replace message.
Yes.
Yeah. Fab. We've got 1 minute left, so I am going to unfortunately have to wrap up for today. So sorry to anyone's questions that we didn't get through. I'd just like to start by saying, Scott, a huge, huge thank you for hosting this event today, giving us, an insight into the world of AI and providing us with, definitely me, with lots of food for thought, for future thinking. So a massive thank you for being with us. For everyone who's attended, thank you also for joining us today online from wherever you might be in the world. We really hope that you enjoyed today's event. Today's event, as I mentioned at the start, marks the start of this year's NCL Discover series, and we hope to see you back at future events soon. Next up in this series is in November, and Scott mentioned earlier in the talk around sort of online security, data protection, and that is all what our next session is about, the online security in 2024, delivered by Deborah Cairns, who is the Managing Director of Net Defence. There's also a lot more NCL in Action themed sessions and activities coming up between now and Christmas, including an NCL Develop 3-part series on how AI and tech can support your career development. You can also sign up to our Industry Insights program, which is a 60-minute peer mentoring sessions, which aim to connect you with someone working either in your industry or in a similar field to discuss the challenges and opportunities that AI presents for future career landscapes. This is a really good chance to connect with someone new, share wisdom and advice, and gain support for any challenges that you may be experiencing. As always, please get in touch with our team if you want to find out more about the alumni community at Newcastle, or visit our website for full details. A massive thank you, Scott, again, and a final thank you to everyone who joined us today. We can't wait to see you at another event soon. Thank you very much, and enjoy the rest of your day.